Hello everyone in Research Methods, Psych 290. This is section 16 of the reading packet. It's only one section. If we were meeting in class together, we would have lots of discussions about it, but instead, like usual, you get the brief version here from me, the consolidated version. So, quasi-experimental designs. I wish I could say that this is something you're going to use on your paper, but you're not. We don't have anyone doing a quasi-experimental design for their research project. So instead, this is something just that you need to know for your exam. So let's get started. What does quasi mean? It means sort of, kind of, not really, not completely. I guess that would be the definitions I could think of for quasi, not quite a real experiment. Some of this will sound a little familiar because it's similar to, yet not exactly the same as the error and the experiment topic we talked about. There are three reasons why these following studies would not be a true experiment. One, you lack randomness. Two, there's no pretest. You don't know what your people were like before you started the study. Or three, there's no comparison group. You don't know what other people are like who didn't get the same treatment or who got a different treatment. So let's get started here. There are four that are called uninterpretable because they have two or three of those problems I just mentioned. The last four are called interpretable because they have only one of those problems. So let's get started. First one group post-test only. Here we have those O's again. The O is when you measure somebody, test them, give them the survey, whatever you're doing, and the X is the treatment or the intervention, what happened to them. So the first one group post-test only design. What do you have going on here? Something happens to the people and you measure them afterwards. True story. I once had someone from ASU East, which is now called Polytechnic, come talk to my psychology research methods class about their bachelor's degree program, and they didn't give me any notice. They emailed me the day they were coming and said, hey, we want to show your students a video and see what they think. Well, there was no control group. I didn't have anybody to compare it to other than the people sitting in the room. I did not have a pre-test because I did not know what my students thought before they watched the video and listened to the speaker. And there was no randomness. My group of students was already in existence. I couldn't pick them at random. Do you see how there were three problems with that study? What do you think after you watch the video and hear the guest speaker? Well, I guess that's nice to know, but it's not very scientific, is it? There was no random selection of people. There was no control group to see what a different group would think of it or under different circumstances. And perhaps most importantly, I did not know what my students thought of ASU Polytechnic's bachelor's degree program before we started that day. So three problems there. Moving right along. What if you could pre-test your people? That is the second one here. Maybe that ASU guy gave me a week's notice, let's just pretend, and therefore I have time to give them a survey of what they think of ASU's bachelor's degree at the Williams campus Polytechnic. That would be interesting, but do you see I would still lack randomness? And not only that, I don't have another group to compare it to see what they think. Still not very scientific. Moving right along. What if I have two groups of people and one of them gets the intervention, but the other one does not? Let me put that check mark back where it should be here. There we go. But you see the problem here? There is no randomness, non-R. And what's missing here? There is no pretest. So maybe something just happens one day and I can't control it, but then I do have a different class and I can compare it to them. But there is no pretest and there is no randomness. Fourth one, we're getting slightly more scientific here, but we still have two problems. Non-equivalent, post-test only, multiple treatment design. Do you need to memorize those words for the exam? Of course not. What if I have three different groups? They're all non-random. See? Non-random, non-random, non-random. Maybe three different psychology classes, but you see what's going on here? There's no pretest. So three different groups, and maybe they're all different. One is abnormal psych, one is research methods, one is statistics. I don't have any pretest. They all go through some sort of treatment, and they all get a post-test here. But two problems. They're not random people, and I have no pretest. So let's move on to the interpretable models. These are ones that are more scientific, therefore you could publish it, but you would just have to be honest in your discussion section and say, these were not random people. They were already at that school. They were already in that hospital. Not random. The first one looks like a regular research study that we're so used to, doesn't it? Where you have a before and after situation, and you have two separate groups of people. This is called control group, pretest, post-test only design. What's the problem here? There are not random people. See, non-random, non-random. Otherwise, this is just a normal study. How come this second group doesn't have an X in the middle? Because they got no treatment. They would be a control group. So therefore, maybe they are asked how they feel about ASU's program before and after, I don't know, the semester or the week, but they do not get the guest speaker who brings the video. See, the treatment is missing here in the middle. So moving right along, the last three to me are more interesting. I don't know if you get excited by research methods topics like I do, but this is more interesting. I think these last three. What if you did a study where you repeated the pretest? What exactly are we talking about here? You do more than one pretest. Look at that, I messed it up again. Let me bring down the pen. More than one pretest. You don't have to do it twice. You could do it 3, 4, 5, or 6 times. What does that mean? Well, maybe I want to know what symptoms you have when you first get to the hospital, and then a week later, and then a week after that. I want to see if you're stabilizing. And then finally, I'm gonna give these people medicine. Maybe it's taking that long. I want to see first if they're stable. So I could do a study just like that, where you give them a pretest first, and then you give them a pretest, and then you give them another pretest maybe, and eventually you give people the treatment. That's what the X is here. And then everybody gets the post-test. Do you see how only one group is getting the treatment and the other group is not? Now, what if you're doing it the other way? Repeated post-tests. This is very common when you could do even more than two, by the way. This is very common when you're measuring whether people are going to stick to a diet a week, a month, a year later, stick with their stop smoking program, stick with, I don't know, online learning. You might measure them before and after something, but then after again, and maybe even another time. That's seeing if they will continue to follow up with whatever it is the intervention was. Exercise, dieting, quitting smoking, or whatever. You might choose to repeat the post-test over and over again. Last one, if you like this stuff, maybe you're like me, and this would be the most interesting. What on earth are we talking about here with repeated, no, I'm sorry, wrong one, added and reduced pretest, post-test? You have to find out how much of something people are used to in the two groups, and then you purposely, as an intervention, give them more or less of whatever it is they were used to getting. So if we were in class together, we would get together and think of examples, and students come up with some interesting ones. What if at work you get more and another group gets less commission than they're used to? Oh, you're used to getting 10% on things that you sell, or $5 per sale, or whatever. That would be interesting to see how sales go when people get more or less commission. What about kids and recess time at school? What if one group gets more recess and the other group gets less? What if it is allowance from your parents when you're growing up? I could think of a whole bunch of examples. And when I have students get together in groups and discuss this, they come up with some cool ideas. What about more or less caffeine in the morning if you're a coffee, tea, or soda drinker? What about more or less sleep at night and how you function during the day? We could think of endless examples, probably, of how you could do added and reduced factors, more and less of whatever it is we're talking about than the person is used to. Or I say person, people, multiple people in the study. So let's go through this just one more time. Quasi-experimental design. What is the problem? Well, there's three problems, and these uninterpretable ones have at least two, if not all three of those problems. And that is no randomness, no control group, and no comparison, or though that's the same thing, no comparison group or no pretest. See, I'm getting a little ahead of myself. The first one here is one group, post-test only. There's no pretest, no randomness, no control group. Second one, at least I tested them beforehand, but what I did not do was randomize or have a control group. Third one, at least now I have a control group, but they're not random and there's no pretest. And the fourth one, same thing. Maybe I have 3 different treatment conditions or more, 4 or 5, but there's no randomness and no pretest. Moving right along, the interpretable ones. The first one here looks like a normal study, doesn't it? But they're not random people. They're pre-existing in their groups. Next one. Here's where it gets interesting to me. Repeating the pretest. Maybe you want to know how people are adjusting to their new situation, so you test them a few times before you throw in the intervention. New school, new hospital, new inmates at the jail. I could think of a lot of examples. You repeat the pretest until you finally give the intervention. Here, repeating the post-test. Maybe you want to see if people are sticking with whatever the independent variable was, the treatment. So you repeat the post-test multiple times, 2, 3, 4, or even more. And the one that I like the best, because I just think it's so darn interesting, is added and reduced factors. You give more or less of something than a person is used to. And then, not a person, people. I keep saying that, groups of people, because you want to see how they are going to react. So, are you allowed to work at home? Maybe we give you more or less of those hours than you're used to. That would be interesting, huh? So again, this is section 16 of the reading packet, Quasi-Experimental Designs, and it's only one page, but there is a lot of stuff to know. So good thing that you watched this video. That's it for now. Take care.